Welcome everyone. I am Ritul Rathod and my teammates are Hitesh Chaudhary, Jamin Makani, Raj Gandhi and Ramesh Rajguru. We are the student of SRI City and currently pursuing BE in Chemical Technology, Dyes and Pigment Department. We are working on our final year project that is Synthesis of Reactive Black 5 and its plant proposal. This project is guided by Dr. Nilesh Bargujjar. The main aim of our project is to synthesize reactive black 5 and give its plant proposal. Further will be continued by Hitesh Chaudhary.
Thank you, Rital. I, Hitesh Chaudhary, like to talk about the main objective of our project is that using same diazo and coupler, we are synthesizing different shades by adding alkali and maintaining temperature. According to our project, the raw material used are vinyl sulfone, H acid, sodium nitrate, and HCl. Apparatus required are beaker, petri dish, spatula, stirrer, pH meter, thermometer, hot air oven, and ball mill. This dye is applied on cotton and wool. Further will be explained by Raj Gandhi.
Thank you, Hitesh. I am going to explain methodology. First, start from diazodization. Vs charge to MSRL reaction vessel along with water and ice to maintain temperature between 0 to 5 degrees Celsius. Then hydrochloric acid will be added followed by sodium nitrite gradually till the diazodization complete, which can be confirmed by starch iodide paper. Any excess nitrite will be removed by adding sulfamic acid just before coupling. Keep temperature between 0 to 5 degrees Celsius throughout the diazodization reaction. First coupling. Charge H acid to the diazodized BNTS and stir it. Keep the temperature between 0 to 5 by adding ice. Second coupling. OAVS charge to MSRL reaction vessel along with water and ice to maintain temperature between 0 to 5 degrees Celsius. Then hydrochloric acid will be added, followed by sodium nitrite powder gradually till the diazodization complete, which can be confirmed by starch iodide paper. Any excess nitrite will be removed by adding sulfamic acid just before coupling. Keep temperature between 0 to 5 degrees Celsius throughout the diazodization reaction. Further continue by Jaimin Makani.
Thank you, Raj. After that experimental work we have performed. In figure 1, here diazotization reaction take place. In this formation of diazonium ion from vinyl sulfone. After that figure 2 indicate the coupling reaction. In that diazonium ion is attached with H acid. After that observation we have done in our experiment. Figure 3, testing of pH using Congo red paper, where the paper turn into the blue color when pH is 1 to 3. After that in figure 4, temperature measurement. In that, throughout the operation we have to maintain the temperature between 0 to 5 degrees Celsius. In figure 5, solubility test. In that, 1 drop of dye put into the 1 liter of water. In figure 6, starch iodide paper. It indicates that the sodium nitrate is excess or not. The paper turns into blue when it is an excess. After that, figure 7, spot test. It shows that which color is obtained after the reaction of diazo and coupler.
Thank you, Chairman. Now we move towards the result and conclusion. In result, we have discussed about the dyeing parameters and dyeing process. In figure 8, it indicates that the effective dye temperature on color yield. It is necessary to optimize the dyeing parameters such as temperature and time. To begin with, effective temperature, keeping the time constant for 80 minutes, the effective temperature of color yield of cellulosic fiber dye with reactive black 5. The color yield of reactive black 5 increase gradually with increase in dyeing temperature from 40 degrees centigrade to 60 degrees centigrade with slow increase in 60 to 70 degree. The color yield of high dyeing temperature 80 degree remained same. This is due to the high dyeing temperature that lowers the ratio of dye that leads to accelerate the dye hydrolysis. In figure 9, it indicates the effect of dyeing temperature on color yield. The higher dye take up an optimum dye of cellulosic fiber at 70 degrees centigrade. This temperature was used for determining optimum dyeing time. Reactive black 5. Higher increase in color yield can be observed from 10 minutes to 20 minutes, thereby maximum color yield obtained until 30 minutes of dyeing time. In figure 10, comparison of color yield between infracolor dye cellulosic fiber and conventional dye cellulosic fiber. Comparison of infracolor dye and conventional dyeing on cellulosic fiber results that the infracolor dyeing shows high color yield than the conventional dye for both dyes. Colored dyes of cellulosic fiber dye with reactive black fiber cellulosic dyeing shows 20.35% higher than the cellulosic fiber dyed by conventional dyeing. In figure 11, it indicates the color fastness performance of cellulosic fiber. The color fastness of washing, shade change and staining and light fastness tests were conducted on cellulosic fiber dyed with 3% dye concentration of reactive black 5, 70 degrees centigrade for 30 minutes. The staining in washing fastness test of reactive black 5 has attained maximum rating, which indicates no bleeding and therefore good dye fixation. The cellulosic fiber dyed with reactive black 5 has been better light fastness. At the last, I just want to conclude that the cellulosic fiber dyed with reactive black 5 by batch dyeing method, infracolored dyeing shows higher color yield than the conventional dye. In comparison of color yield, cellulosic fiber dyed with reactive black 5 by infracolor dyeing shows 20.35% higher than the cellulosic fiber dyed by conventional dyeing, higher color yield. The color fastness result of both reactive dyes revealed no bleed during washing and indicates good light fixation. Thank you all for paying attention. Thank you.